Subscribe for daily videos. Cloud computing is the delivery of computing resources over a network, usually the internet, so you can use infrastructure and services without owning and operating all of the underlying hardware yourself. Instead of buying physical servers, installing them in a data center, connecting networks, managing storage, and maintaining the hardware, you can provision many of those resources from a cloud provider when you need them. The important idea is not simply that your computer is somewhere else. Cloud computing is a model built around on-demand access to a shared pool of configurable computing resources that can be provisioned and released with relatively little manual interaction. That's the formal concept described by the National Institute of Standards and Technology, or NIST. So, what does that actually mean? Imagine you are building a web application. You need somewhere to run your application. You need storage for data and files. You need networking so users can reach the application. And depending on the architecture, you might also need databases, queues, monitoring, identity services, load balancing, and many other components. With traditional infrastructure, your organization may purchase and operate the physical equipment needed to provide those capabilities. With cloud computing, you can consume many of them as services. You choose the resources you need, configure them, and the provider operates the underlying physical infrastructure. That gives cloud computing one of its most important characteristics: on-demand self-service. You can provision computing capabilities when you need them, often through a web console, API, command line tool, or infrastructure as code system. Another important characteristic is resource pooling. Cloud providers operate large pools of computing, storage, and networking resources. Those resources can be dynamically allocated to different customers while maintaining logical separation between their environments. This is one reason the cloud can operate at a very large scale. Then there is elasticity. Suppose your application normally receives 1,000 requests per minute, but suddenly receives much more traffic. Depending on the architecture and the cloud service you're using, additional resources can be provisioned or existing resources can scale. When demand decreases, capacity can sometimes be reduced as well. But there is an important detail here. Cloud computing does not mean infinite or automatic scalability. Scaling depends on the architecture, service limits, configuration, workload, and how the application has been designed. The cloud provides mechanisms for scaling. Your architecture still has to use them correctly. Cloud computing is also commonly discussed through 3 service models: infrastructure as a service, or IaaS. Here, you receive fundamental infrastructure resources such as virtual machines, storage, and networking. You have more control, but you also manage more of the software stack. Platform as a service, or PaaS. The provider manages more of the underlying platform, allowing you to focus more on your application rather than operating virtual machines and operating systems yourself. And then there is software as a service, or SaaS. Instead of building and operating the application yourself, you simply use a finished software service. Email, collaboration software, and many business applications are examples of this model. These categories aren't just marketing terms. They describe different points on the spectrum of how much of the computing stack you manage yourself. NIST defines IaaS, PaaS, and SaaS as the 3 cloud service models in its cloud computing framework. Now let's talk about what actually happens underneath. A cloud data center still contains physical computers. There are processors, memory, storage devices, network equipment, power systems, cooling systems, and physical security. The cloud doesn't eliminate physical infrastructure. It abstracts much of that infrastructure behind software and services. Virtualization is one important technology used in cloud infrastructure. A physical server can host multiple virtual machines, allowing computing resources to be allocated more flexibly. But virtualization is not the entire definition of cloud computing. Cloud platforms also combine networking, storage, automation, orchestration, APIs, identity systems, monitoring, managed databases, and many other services. The result is a layer of abstraction between the application developer and the physical infrastructure. And this abstraction is one of the biggest reasons cloud computing changed how software is built and operated. Instead of thinking primarily in terms of physical machines, teams can think in terms of resources and services. Need a database? Provision one. Need object storage? Create a storage resource. Need more compute capacity? Scale the appropriate service. Need infrastructure in another geographic region? If the provider supports it, you can deploy there. The exact capabilities depend on the provider and service, but the underlying model is the same. Consume computing capabilities as services instead of manually operating every physical component. There is also an important economic difference. Cloud computing can turn some infrastructure expenses into usage-based operating expenses. Instead of purchasing hardware years in advance, an organization can consume resources according to its needs and the provider's pricing model. But cloud does not automatically mean cheaper. A poorly designed cloud architecture can become expensive. Unused resources, excessive data transfer, over-provisioned infrastructure, and inefficient workloads can all increase costs. So the cloud changes the way infrastructure is acquired and operated. It doesn't eliminate the need for engineering decisions. And then there's security. One of the biggest misconceptions about cloud computing is that moving to the cloud means the provider takes care of all security. That's not how modern cloud environments work. Cloud security is generally based on a shared responsibility model. The provider is responsible for securing parts of the underlying infrastructure, while the customer remains responsible for things such as data, identities, access controls, applications, and other components depending on the service being used. The exact division changes between IaaS, PaaS, SaaS, and individual cloud services. So cloud computing is not simply someone else's computer. That's a useful joke, but it misses the important engineering concept. Cloud computing is an operational model for delivering computing resources and services through network access, with characteristics such as on-demand provisioning, resource pooling, elasticity, and measured usage. And today, cloud infrastructure can range from raw virtual machines to fully managed databases, serverless platforms, storage systems, networking services, analytics platforms, and complete software applications. The key shift is abstraction. You don't necessarily need to know which physical server is running your application. You interact with the service. The cloud provider manages much of the infrastructure beneath that service. And as a developer or organization, you decide how to compose those services into a system. That's what cloud computing really is. Computing infrastructure and capabilities delivered as services, abstracted from much of the physical infrastructure, and designed to be provisioned and consumed on demand. Once you understand that idea, technologies like virtual machines, containers, Kubernetes, serverless computing, managed databases, and cloud storage become much easier to put into context. They are different ways of building and operating systems within or alongside the broader cloud computing model.